Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, we will continue our discussion about plane waves and good conductors, and we will solve a problem based on good conductors. So we already found the relation between alpha and beta, which is going to be equal in case of good conductors, and that is equal to root of pi f mu into sigma. And the intrinsic impedance also we have already computed, that is equal to root of omega mu by sigma into angle 45 degree, right? And we found a skin depth which is going to be the reciprocal of the attenuation constant alpha. And combining all the uh, three, and we can write the intrinsic impedance in terms of the skin depth, that is del. So if you uh, do the simplification, we will get 1 by conductivity into the skin depth, and we get one more root because you substitute okay, for this term I have to substitute 1 by del, means you think in del there is one root of sigma in the denominator. So to take that, I am multiplying and dividing on both sides, numerator and denominator, by sigma. Okay, this so I will get 1 sigma outside this root, and this 1 by del will come. And for omega we get 2 pi f, right? That root 2 also comes out. So for that j term, okay, for this angle 45 degree, we are writing in terms of exponential e power j pi by 4. If we take cos of pi by 4 plus j sin pi by 4, cos pi by 4 is what? 1 by root 2. J sin 5 by 4 also 1 by root 2. So root 2 get cancelled. I will get 1 plus j in the numerator and sigma by del in the denominator. Okay. We will use this to find the skin resistance actually. The skin depth is used to calculate the AC resistance due to the skin effect. Okay, because of the skin effect, that is the AC resistance. For that, the skin depth is useful. So the DC resistance is given by, we already know DC resistance, it is rho L by A, where rho is the resistivity. That resistivity is known as reciprocal of, so we can write DC resistance as L divided by sigma into surface area. To find the surface or skin resistance in ohms, we are going to take the real part of the intrinsic impedance of the good conductor. So it is going to be 1 by sigma into del. So if you substitute the values for del, we get the root of pi f mu divided by sigma. So this is a resistance of unit width and unit length of conductor, and it is equivalent to DC resistance, like an equivalent to DC resistance for unit length of conductor having the cross section 1 cross del. Okay. Now if suppose the conductor length and the W and L and W, AC resistance is calculated from the DC resistance. So AC is nothing, L is will be there as it is, divided by um, sigma. For surface area, it is del into W. So we are considering the thickness as del. Surface area is del into W. So we can write the AC resistance. If you see this formula, it's 1 by sigma del, right? So that is replaced by RS, skin resistance. So if we take the ratio of AC resistance to the DC resistance for a conductor wire of radius A, the width is going to be the circumference of that circular conductor, right? That is 2 pi A. So AC, what I should replace, L divided by sigma, instead of it's 2 pi A, del remains the same. For the DC resistance, we know it is L divided by sigma into surface area. Surface area for the circle is pi r a square. Okay. So simplifying, we get this expression. So the AC resistance is greater than the DC resistance. Okay. And it increases as the frequency increases also, because frequency is in direct relation. Now let us solve the given problem. A uniform plane wave is propagating in a medium and has the electric field 2 e power minus alpha z sine of omega t is given minus beta z into the unit vector for the electric field component volt per meter they have given, and the medium properties like permittivity, permeability and conductivity is given. They ask us to find attenuation, phase constant and the expression for magnetic field. So seeing the expression, we can find since e power minus alpha is it there, it is not a lossless dielectric, right? Lossless means attenuation will be zero. And since the material properties are given relative permittivity and permeability, it is not free space. For free space, they won't mention. So our choice is whether we have to find whether it is a lossy dielectric or a good conductor. How will determine by finding the loss tangent value. Only that parameter will help me to find whether it is a lossy dielectric or a good conductor. So loss tangent is nothing sigma by omega epsilon. So sigma is 3, it's given. Omega is 10 power 8. Okay, and for epsilon, it is we know it not into epsilon r. So epsilon r is 1. Epsilon naught, we know it is 8.854 into 10 power minus 12. Same is written in a different way. So we can see it is very, very large compared to 1. So it is a good conductor. In good conductors, we know alpha, beta both are same, and it is equal to root of mu omega sigma by 2. So for mu, substitute mu naught into mu r. Okay, mu r is 20 here, and omega it is 10 power 8. For sigma it is 3, and everything take a root, we get answer. So for alpha beta both the values are same, but the units are different. Here it is Nepper per meter, here it is radian per meter. Now to find the magnetic field, we need to find what is the magnitude of the magnetic field H naught, and what is the direction of that magnetic field, as well as what phase shift it is undergoing. For that, it's first we have to find since the relation we know H naught is equal to E naught by eta, from that only we can find the magnitude, right? Already E naught is given in the question, it is 2. We are supposed to find the magnitude of eta. For the good conductor, we know it is mu omega by sigma. Substitute all the values and we get this answer. And to find the phase shift, we have to find tan 2 theta eta, that is equal to sigma by omega epsilon. So theta eta we are supposed to find. We already found this value, right? Take tan inverse, okay, and divide that answer by 2, we get 45 degree. And the expression for magnetic field remains the same. Similar to the electric field, it is H naught e power minus alpha z sine of omega t minus beta z. The phase shift is pi by 4. The unit vector we have to find. So AH is equal to AK cross AE. That is AK is the direction of the wave propagation. That is positive is the direction, right? AZ. For AE, it is given AY. And if you cross multiply AZ cross AY, it is going to be minus AX. So we found the unit vector. Okay, negative sign is given before. So to find H naught, divide E naught by eta, we get this answer, and we are substituting here the alpha value also 61.4 that we found, and omega it's already given, beta also same like that of alpha. Everything we are substituting, and we are writing the answer in terms of milliampere per meter. The general unit is thank you everyone. I you understood how a wave is propagating in good conductor, where it is supposed to undergo a phenomena called skin effect, and we have seen a problem based on the good conductors. Thank you everyone. We will meet next time. Happy learning.